start by exploring the concept of pressure, a fundamental idea in biomechanics and physics. Pressure is defined as the force applied per unit area over which the force acts. To calculate pressure, you simply divide the force by the area. This measurement is crucial because it helps us understand how force is distributed across surfaces, which is especially important in analyzing human motion and safety. Standard unit for pressure is the Pascal, which is equivalent to 1 Newton per square meter. For example, imagine being stepped on by someone wearing high heels versus athletic shoes. The same force is applied, but the smaller area of the heel increases the pressure, making it much more painful. This real-world scenario highlights why understanding pressure is so important in biomechanics. Next, let's discuss three closely related concepts: volume, density, and specific weight. Volume refers to the amount of three-dimensional space an object occupies, measured in cubic centimeters, cubic meters, or liters. Interestingly, objects can have similar volumes but very different weights. Density, represented by the Greek letter rho, is the mass per unit volume and is measured in kilograms per cubic meter. Specific weight, on the other hand, is the weight per unit volume, with its metric unit being newtons per cubic meter. These concepts are interconnected. For instance, a shot put and a softball may have similar volumes, but the shot put has a much greater mass and density, resulting in a higher specific weight. Understanding these differences is essential for analyzing how objects behave in motion and under force. Now let's move on to torque, a key concept in understanding rotational motion. Torque, often symbolized as T, is the rotary effect of a force and is sometimes called the moment of force. It is the angular equivalent of linear force. To calculate torque, you multiply the force by the perpendicular distance from the force's line of action to the axis of rotation. For example, if you apply a force of 10 newtons at a distance of 2 meters from the axis, the resulting torque is 20 newton meters. This principle is crucial in biomechanics as it helps explain how our muscles and joints produce movement. The images here illustrate different ways torque can be generated and how it affects rotation around an axis. Finally, let's talk about impulse, another important kinetic concept. Impulse is the product of force and the time over which the force acts, and it is denoted by the letter J. The formula for impulse is J equals force times time, J equals F times T, and its unit is Newton seconds ns. Impulse helps us understand how forces applied over different periods can affect motion. For example, a quick sharp force and a longer sustained force can produce very different outcomes, even if the total impulse is the same. This concept is widely used in sports science, rehabilitation, and safety engineering to analyze and improve human movement. By mastering these kinetic concepts, pressure, volume, density, specific weight, torque, and impulse, you gain a deeper understanding of how forces shape our world and our bodies.